So hello, everyone. This is Kuanyi Zhang from Sichuan University. Today, I want to introduce our paper, Utilizing Implicit Feedback for User Mainstreaminess Evaluation and Bias Detection in Recommender Systems. In this workshop, I think most people are familiar with popularity bias. Popularity bias refers to that recommender systems favor popular items and harms the item fairness. But how about mainstream bias? As we can see in the pictures on the right, there are many studies about popularity bias in past 5 years, but there are very few studies about mainstream bias. Mainstream bias refers to that recommender systems favor mainstream users, so it harms the user fairness. Different from popularity bias, it's hard to perceive this bias from the user side. Before diving into mainstream bias, we must figure out what is mainstream. So mainstream have different meanings in different recommendation scenarios. In this paper, we only consider the implicit feedback and provide a universal definition. We conclude that mainstream represents the preferences of most users in the same group. On the right pictures, we could see clearly long-tail distributions. There are two main reasons that user interactions form the long-tail distribution. The first one is lots of users have similar tastes. The second one is user contributions to the short-head items. So we want to investigate mainstream bias, but who are mainstream users? Now, there are two intuitive ways to identify mainstream users. The first way uses the amount of similar users and assumes that users with more similar users are more mainstream. The second way considers users' preferences to popular items. A typical method is using the ratio of popular items in one's profile. We insist that the second way is more reasonable. As we could see in the picture, there are two users who have the same number of similar users, but their preferences are totally different. Now let's get into the mainstream evaluations. So in past studies, researchers usually divide users into 2 groups or 3 groups, but this grouping method ignores user differences. Users in the same groups have different mainstreamness, and it's too cross-grained that the results cannot be used to do the de-bias research. We think quantifying users' mainstreamness is a better choice. Some researchers use recommendation utility to do this evaluation. Is unreasonable because the results would be model related. Zhang et al. Treat the evaluation tasks as an outlier detection problem and assign every user a mainstream score. They introduce 4 different approaches for mainstreamness evaluation, and we employ these approaches as baselines. In our paper, we propose a simple and an intuitive approach for user mainstreamness evaluation. According to this equation, a user's mainstream score could be easily calculated. The log function is used to suppress the magnitude of item popularity. Then, all consumed items' popularity would be summed up. After that, we use the profile size to average the sum. Now we could evaluate users' mainstreamness by our approach, but does our approach show better effectiveness than others? Now we face an evaluation problem that there is no data sets with ground truth labels of mainstream users. In past studies, Zhang et al. Create a synthetic data set for evaluating their approaches, but we argue that the synthetic data sets have some evident distinctions from the real-world situations. So it's not appropriate for testing these approaches. In our paper, we compare these approaches on real-world public data set To solve the evaluation problem, we sort users by the ratio of popular items in profile, and the top 20% users are labeled as mainstream users. The labels are not very accurate, but it works in some degree. We use 6 data sets to test these approaches. The statistics of this data set could be seen in the figure below. Besides, for the test of investigating the mainstream bias, we explore 4 different recommendation models and 2 metrics in our next experiments. Here is our first experimental results. We compare our mainstreamness evaluation approach with 4 baselines. We use recall as the metric here to see how many mainstream users these approaches could identify. As we could see in the table, our approach showed the best results than others with stable performance in different recommendation scenarios. In these slides, we group all users by their mainstream scores from low to high and get 5 mainstream subgroups to investigate mainstream bias. The red line represents our evaluation approach. Expect the ML1M dataset, we observe the higher mainstream group get the better recommendations on other 5 datasets. But on the ML1M dataset, as the figure in the left corner, we see the abnormal phenomenon that the highest mainstream group get the worst recommendations. To figure out why, we return back to the last step, mainstreamness evaluation. Here, we suspect that users' profile size could be the reason. Here, we group users by their profile sizes from low to high, and we also group them by mainstream scores from low to high. Then we can compute the percentage of overlap for all these subgroups. On the ML1M dataset, the results of 4 baselines shows a remarkably similar pattern, where the positive correlation between profile size and mainstream levels. As can be seen, the values around the counter diagonals are obviously larger than others. But lots of previous studies have revealed a strong negative correlation between the 2 variables. As for our approach, we can clearly observe the negative correlation where values around the principal diagonal are higher than others, matching previous conclusions. Here is the results on the EF dataset. The results of baseline approaches are more even than on the ML1M dataset, but we still see the positive correlations, and our approaches performs better. Now we go back to the mainstream bias. As we notice, profile size could be a confounder. We regroup users by their recommendation utility and calculate the average profile sizes and mainstream scores. In particular, we divide users with NDCG at 20 equals 0 in a 0 group. As we could see in this table, profile size is the main reason for the increase in utility on the ML1M and ML20M datasets, where we see apparently positive correlations. With a much larger profile, a low mainstream user could get satisfactory results. On the other 4 datasets, we noticed that high utility groups achieve the highest mainstream scores, even with a small profile size. On the last FM dataset, we see the mainstream bias clearly that the average profile size of each group is very close, while groups with higher mainstreamness get better results. To see how mainstreamness impacts the recommendation utility, we group users with close profile sizes to eliminate its effect. Then we calculate the Spearman coefficients between the mainstream score and the recommendation utility with statistical significance tests for each group. As we can see the second column in this table. The average correlation coefficients on this data sets are all positive, which indicates various degrees of mainstream bias exist. Additionally, we find that both the profile size and the mainstream scores for the zero group are virtually smaller than any other in almost all data sets, implying that cold start users with low mainstreamness tend to receive the most unfair results. Okay, now we enter the last part. In this paper, our new intuitive approach outperforms others on evaluating user mainstreamness. And we find that the profile size and user mainstreamness are two key factors which influence the recommendation utility. Next, we find that mainstream bias exists extensively in various domains. In future work, we also notice that duplicate consumptions need to be considered, which can also reflect users' preferences. And we are planning to use mainstream scores to improve fairness and utility. The last one, as the popularity could be dynamic, so the mainstreamness could be dynamic too. Thank you for your attention. If you want to see more details, you can click this link or scan the code to see our code and results. Thank you.